Hello my dear students, welcome to Physics Wala. My name is Satish Kumar and I am your chemistry teacher for Abhiyaan Batch, and today we are going to continue the atomic structure, right? We have already discussed about the atomic structure in the previous classes. Manamu atomic structure lo atomic models gurinchi discuss chesnam. Dalton's atomic model, Thomson's atomic model, inka Rutherford atomic model gurinchi kuda discuss cheyadam jarigindi. Dan tarvata Bohr's atomic model chadukodaniki we have tried to observe the latest developments, not latest ante ikkupudunna developments kaadu. At that time we have tried to understand the new development at that time, that is development in the electromagnetic radiation we have studied, and we have studied about the Planck's quantum theory, right? These developments we have studied to understand Bohr's atomic model. And inkoka development kuda manam chadukovalsi undi, adentidi spectrum. Spectrum is also useful to understand the Bohr's atomic model. That's why we are now studying in this session. In this session, we are now studying what? Spectrum, Bohr's atomic model, and also we will be studying hydrogen emission spectrum, and also we are going to study de Broglie wave equation and Heisenberg uncertainty principle. Okay, so now we are going to start the very first topic, that is spectrum. So what do you mean by spectrum? Spectrum is the impression. Spectrum is the impression. Impression is nothing but what? Image. Impression is image produced on a screen, on a photographic screen, when radiations of particular wavelengths are analyzed through a nickel prism or diffraction or grating. Spectra are broadly classified into two types. One is mainly emission spectrum, another one is absorption spectrum. So before studying emission spectrum and absorption spectrum, we need to understand the spectrum very clearly. So what do you mean by spectrum? Spectrum is a image or impression produced on a photographic screen when light of different wavelengths or when radiations of a particular wavelength are passed through the nickel. They will produce one image. That image we are calling it as spectrum. See carefully now. So for example, we are having a light source. What light source we are having? White light source. Manaki ikkada white light ni produce chese oka source undi, whatever it may be, a lamp or a tube light, anything which is producing what light? White light. White light consists of what? White light means visible radiation. White light means what radiation? Visible radiation. Visible radiation lo enni colors untavi? 7 colors untayi. Violet, indigo, blue, green, red, orange. So ee white light source nunchi white light pass ayindi. It is falling on the water nickel prism మీద వేసాం. వేసినాక this light will be deviated through this prism into how many colors? 7 colors. 1, 2, 3, 4, 5, 6 and 7. So ఈ light ఏమైంది? Deviate అయ్యి it is split into 7 colors. So if you keep one photographic plate here, these 7 different frequencies and different wavelengths, frequency వేరుగా ఉందంటే wavelength కూడా different గానే ఉంటుంది. ఈ 7 different types of wavelengths and frequencies will fall on the photographic plate, so that we can able to find 7 different colors on the photographic plate. So the image or impression we will be getting because of this 7 different colors. This image we got here, this image of 7 colors is called as what? Spectrum. Spectrum is what? Image recorded, image recorded on screen when a light of different frequencies, a light of different frequencies, a light of different frequencies and wavelengths are analyzed through a prism. We have analyzed what light here? White light. White light ni దేని నుంచి అనలైజ్ చేసినాము? నికెల్ ప్రిజం నుంచి అనలైజ్. వైట్ లైట్ ఈజ్ మేడ్ అప్ ఆఫ్ what frequency, what wavelength to what wavelength? 480 nanometers, 480 nanometers to 700 nanometers. Visible radiation యొక్క wavelength range ఏందమ్మా? 480 to 700 nanometers. 480 nanometers to 700 nanometers. 480 nanometers is there for violet color and 700 nanometers wavelength is there for red color. It means violet color is having what wavelength? Less wavelength. And red color is having what wavelength? More wavelength. As it is having more wavelength, red color is having more wavelength, it can travel for a long distance. And that is the reason why at signals, they used to keep red color to stop us. Signals దగ్గర స్టాప్ చేయడానికి రెడ్ కలర్ సిగ్నల్ ఎందుకు పెడతారంటే దీని వేవ్ లెంత్ ఎక్కువ ఉంటుంది. రెడ్ కలర్ వేవ్ లెంత్ ఈజ్ మోర్. ద రెడ్ కలర్ విల్ ఫార్మ్ ఏ వేవ్ విత్ లార్జర్ వేవ్ లెంత్. రెడ్ కలర్ అనేది లార్జర్ వేవ్ లెంత్ని తోని వేవ్ని ఫామ్ చేస్తుంది కాబట్టి ఇట్ కెన్ రీచ్ టు ది లాంగ్ డిస్టెన్స్. అంటే ఈ వేవ్ లెంత్ ఎక్కువ ఉండడం వల్ల రెడ్ కలర్ అనేది చాలా దూరంగా ఉన్న వ్యక్తులకు కూడా మనకి క్లియర్గా కనబడుతుంది. అందుకని సిగ్నల్స్ దగ్గర రెడ్ కలర్ని వెహికల్స్ స్టాప్ చేయడానికి వాడుతున్నాం. సో వెన్ వైట్ లైట్ ఈస్ పాస్డ్ త్రూ నికెల్ ప్రిజం, ఇట్ స్ప్లిట్ ఇంటూ 7 colors. Okay, in white light what wavelength to what wavelength radiations are there? 480 nanometers to 700 nanometers. It means it includes violet, indigo, blue, green, orange, all the VIBGR colors. So here we kept one photographic plate. This light split into 7 colors and recorded one image here that is called as spectrum, right? This spectrum is broadly classified into how many types? Mainly 2 types. One is emission spectrum, another one is absorption spectrum. So first of all we'll see what is emission spectrum. See carefully now. When the radiation emitted from some source, light ekkadi nunchi emit ayindi, edo oka source nunchi emit ayindi. Em sources avi? From the sun nunchi gaani, or by passing electric discharge through a gas. Ante we will be taking one gas. Okay, in this what particles are there? Gaseous particles are there. So we are passing some electrical energy into these gaseous particles. These gaseous particles absorb electrical energy and will generate some electromagnetic radiation or light. That is what you mean by passing electric discharge through gas at a low pressure, or by heating some substances to high temperature. ఏదైనా ఒక సబ్స్టెన్స్, ఇవి నిన్న చెప్పాం మనం, ఏంటిది? ఐరన్ బాల్ ఈజ్ హీటెడ్ టు రెడ్ హాట్. సో ఇట్ జనరేట్ వాట్? ఎలక్ట్రిక్ ఫీల్డ్ అండ్ magnetic field. It will be generating what? Electromagnetic radiation having certain frequency and certain wavelength. So if you can do any of these things, when the radiation emitted from the source, ఈ వీటిలలో ఏ పని చేసినా మీకు ఏమి ఎమిట్ అవుతుంది? రేడియేషన్ ఎమిట్ అవుతుంది. ఇప్పుడు సన్ నుంచి రేడియేషన్ ఎమిట్ అవుతుంది. అండ్ ఇఫ్ యూ కెన్ పాస్ ఎలక్ట్రిక్ కరెంట్ త్రూ గ్యాస్ ఆల్సో ఎమిట్ రేడియేషన్, ఆర్ ఎల్స్ ఇఫ్ యూ హీట్ ఏ సబ్స్టాన్స్, దట్ సబ్స్టాన్స్ విల్ ఆల్సో ప్రొడ్యూస్ రేడియేషన్. సో చేసినప్పుడు ఏమవుతుంది అంటే, ఇఫ్ దట్ రేడియేషన్ ఈజ్ పాస్డ్ త్రూ ప్రిజం, ఇక్కడ ఎమిట్ అయిన రేడియేషన్ని మనం ప్రిజం నుంచి పాస్ చేస్తే, then the received on the photographic plate, the spectrum obtained is called as emission spectrum. The spectrum of radiation emitted by substance is is in its excited state is an emitted spectrum. See, when the radiation emitted from this source, okay, is passed directly through the prism, and then the received, the photographic plate, received on photographic plate is called as what? Emission spectrum. It means, so we have heated one gas here. For example, gas molecules ni baga heat chesina. Heat chesinapudu emaitadi, particles absorb the heat, and whenever this particle absorb the heat, they can get accelerated. If they get accelerated, electric field and magnetic field is generated and traveling in this direction. We call it as this as what? Electromagnetic radiation. Deenni manam emantunnamo? Electromagnetic radiation amantam. Deenni, if you keep one prism here, ikkada oka prism ni pettina, this electromagnetic radiation is falling on this prism and is deviated into different colors, and we are recording this on a photographic plate. The different colors we have recorded on the photographic plate, and this is called as what? Emission spectrum. Endukante emission spectrum means we are heating it. Because of heat, this substance is emitting some radiation. Emission spectrum is the image recorded when a substance is emitting the radiation. When a substance is emitting radiation, right? So, emitted radiation, it means, for example, see carefully, we have a white light source here. White light source. White light source undi. White light source nunchi ఏ కలర్స్ వస్తాయి? VIBGR కలర్స్ వస్తాయి. From this source we are heating a gas. White light ni తీసుకొని మనం ఏం చేస్తున్నామంటే we are heating the gas, so that this gas is absorbing some radiation, and it is emitting the remaining radiation. Like this. And it is only giving red, orange, green colors only on the photographic plate. Photographic plate మీద ఏ కలర్స్ వచ్చినాయి? రెడ్ కలర్, ఆరెంజ్ కలర్, గ్రీన్ కలర్ మాత్రమే వచ్చినాయి. So these three colors are emitted by this gas. That's why this is called as what spectrum? Emission spectrum. What spectrum this is? Emission spectrum. Okay. And next, absorption spectrum. See, emission spectrum is two types. One is continuous spectrum, another one is discontinuous spectrum. Continuous spectrum means when white light from the any source such as sun or bulb, any hot glowing body analyzed by passing through a prism, it is observed that split into 7 different colors. See carefully. Electric white arc, white light source idi. White light source oka slit unna plane nunchi pass chesam. Pass cheste ekkada padindi? Nickel prism మీద పడింది. నికెల్ ప్రిజం మీద పడి ఏమైంది? రిఫ్లెక్ట్ అయింది దేని మీద? ఫోటోగ్రాఫిక్ ప్లేట్ మీద. ఎన్ని కలర్స్ని ప్రొడ్యూస్ చేసింది? 7 కలర్స్ని కంటిన్యూస్గా ప్రొడ్యూస్ చేసింది. కాబట్టి దీన్ని ఏమంటున్నాము? కంటిన్యూయస్ స్పెక్ట్రమ్, కంటిన్యూయస్ ఎమిషన్ స్పెక్ట్రమ్. ఎందుకంటే we are passing electromagnetic radiation on a surface. This surface absorbed radiation and emitted radiation. So we have recorded on the photographic plate what radiation? Emitted radiation. Kabatti this is emitted radiation, and it is producing all frequencies of white light. All frequencies of white light, that is violet frequency, indigo frequency, blue, green, orange, yellow, red. Continuously it is producing. So this is called as what spectrum? Continuous spectrum. And next is discontinuous spectrum. See now, discontinuous spectrum is like this. So when gases or vapors of a chemical substances are heated in electric arc or in Bunsen flame, light is emitted. If the ray of this light is passed through a prism, a line spectrum is produced. So ikkada this gas, so we have taken one gas here. ఇక్కడ మనం ఒక గ్యాస్ తీసుకున్నాం. దీన్ని హీట్ చేసినాం ఫ్లేమ్ తోటి. దిస్ ఈజ్ అబ్జర్వ్డ్ సమ్ గ్యాస్ some amount of radiation and emitted some other amount of radiation. How many lines are there? 1 2 3 4 5 6 7. So it is emitting only certain kinds of radiation. It is emitting radiation frequency is equals to red color. It is emitting frequency is equals to yellow color. It is emitting frequency is equals to green color. It is emitting frequency is equals to blue color. So it is absorbed some radiation and remained radiation it is released. So this is discontinuous. It is not continuously giving all the colors. Okay. So whether it has to give all colors or some colors, it depends on the nature of the material. Some colors will give continuous spectrum, some material will give continuous spectrum, some other material will give discontinuous spectrum. Discontinuous spectrum means what? That material absorb ఇందులో వైలెట్ లేదు అంటే వైలెట్ కలర్ రేడియేషన్ని కంప్లీట్గా సబ్స్టాన్స్ ఏం చేసిందని అర్థం, అబ్జార్బ్ చేసుకుందని అర్థం. రెడ్ కలర్ని సబ్స్టాన్స్ అబ్జార్బ్ చేసుకోలేకపోతుంది, అందుకే ఏం చేసింది, మళ్ళీ ఎమిట్ చేసిందని అర్థం. సో డిస్కంటిన్యూస్ స్పెక్ట్రమ్ మీన్స్ when gases or vapors of chemical substances are heated in electric arc or in a Bunsen flame, light is emitted. If the ray of its light is passed through prism, a line spectrum is produced. Discontinuous spectrum is also called as line spectrum. Continuous spectrum is also called as band spectrum. Discontinuous spectrum is also called as line spectrum. Continuous spectrum is also called as band spectrum. A discontinuous spectrum consists of distinct and well-defined lines with a dark areas in between. Is called as line spectrum. It is also called as atomic spectrum because this discontinuous spectrum is produced by atoms. Okay. The emission spectrum consisting of series of very closely spaced lines is called as band spectrum. Closely spaced lines unto the name antaru band spectrum antaru. And next, so these are the differences between line spectrum and band spectrum. Sorry, that is emission spectrum and absorption spectrum. And next, this is called absorption spectrum and this is emission spectrum. Emission spectrum lo endi well defined lines are observed, and absorption spectrum lo we have very closed lines. Okay. And next, Bohr's atomic model. Next topic is Bohr's atomic model. In Bohr's atomic model, to overcome the objections of Rutherford atomic model, Bohr explained a new model called as Bohr's atomic model. In Bohr's according to Bohr's atomic model, the very first point of Bohr atomic model is atom is a sphere-shaped particle. Atom is a sphere-shaped particle. The total mass of the atom is present at the center, in which we have protons and neutrons. This center, where the total mass is present and is having protons and neutrons, is called as what? Nucleus. Nucleus ekkada untundi? Center lo untundi. Andulo protons and neutrons untavi. Atom yokka mottam mass dadapuga nucleus lone kendrikrutamai untundi. So protons and neutrons together is called as nucleons. Proton plus neutron is called as nucleon. One proton plus one neutron is called as one nucleon. Two protons, two neutrons is called as how many nucleons? Two nucleons. So nucleus lo emuntavi? Protons and neutrons untavi. Inka, what is the subatomic particle present in the atom? Electron. He also explained about the electrons. Electrons present around the nucleus in a circular path. Electrons present around the nucleus in a circular path. These circular paths he called as what? Orbits. Here the electrons are present like this. So electrons, second point. Electrons are present in the nucleus in a circular, electrons are present around the nucleus, not in the nucleus. Electrons are present around the nucleus in a circular path. That circular paths are called as orbits or energy levels. Orbits are energy level. Why this is called as energy level means each orbit is associated with some energy. Each orbit is associated with some fixed amount of energy, right? That's why these are called as orbits or energy levels, or which are also called as stationary energy levels. Stationary energy levels, because the energy of a particular orbit is fixed. Understand? That's why. And these are indicated with letter n. N values may be 1 or 2 or 3 or 4 or else so on, or k or l or m or n. If orbit value is 1, the electron is present in the first shell or K shell. First shell or K shell. Second shell or L shell. Third shell or M shell. Fourth shell or N shell. Right? So, orbits are named as 1, 2, 3, 4 or K, L, M, N. Orbits are also called as energy levels. Okay. Stationary energy levels, or they are also called as shells. They are also called as shells. And third point is the angular momentum. Angular momentum of the electron. Momentum of electron is indicated with mvr. So this is electron moving with some mass and moving with some velocity. Okay. And the distance between the nucleus and this electron is r. That is known as angular momentum. This electron is moving with some velocity, with some angle, and with some mass and radius. So the angular momentum mvr is equals to integral multiple of the h by 2 pi. Integral means n. It is the multiple of h by 2 pi. Integral multiple of h by 2 pi. This can also be written as nh bar. This h bar is nothing but h by 2 pi. So the angular momentum of the electron which is revolving around the nucleus in a circular path is directly proportional, is equals to integral multiple of h by 2 pi. N is the shell in which the electron is present. It means the angular momentum of electron present in the first orbit. mvr, if n electron is present in the first orbit, it will be n value will be 1h by 2 pi, that is h by 2 pi. If electron is present in second orbit, mvr is equals to what? 2h by 2 pi, that is equals to h by pi. The angular momentum of electron present in the second orbit is h by pi, h by pi. And third case, if n is equals to 3, the angular momentum of the electron mvr is equals to 3h by 2 pi, that is equals to 1.5 h by pi, right? And if n is equals to 4, mvr is equals to 4h by 2 pi, means what? 1 by 2 h by pi, that is 0.5 h by pi. So these are the angular momentum of the electron present in the various orbits. See, here, if the electron is present in the particular orbit, it cannot absorb energy and it cannot emit energy, right? But if electron absorb energy from external source, electron jump from lower orbit to the higher orbit. So what is the next point here? As long as electron is present in an orbit, next point, next postulate, as long as electron is present in an orbit, in an orbit, electron do not absorb or emit energy. It do not absorb or it do not emit energy. But if electron absorb energy from external source, if electron absorb energy, what electron will do? Electron will jump from, electron absorb energy, electron jump from lower orbit to the higher orbit. It jump from lower orbit to higher orbit. Right? దీన్ని ఏమంటాం మనము ఎగ్జైటేషన్ అంటాం. This is called as excitation of electron. Excitation of electron means what? Whenever electron absorb energy, it jump from lower orbit to the higher orbit. Jump from 1 to 2 or 1 to 3 or 1 to 4 or 1 to 5. It depends on the amount of energy that it is absorbed. When the electron absorb maximum energy, the electron absorb maximum energy means it will jump from first energy level to the infinity level. If the electron absorb minimum energy, it jump from first to second. And if the electron absorbs somewhat more amount of energy, it jump from 1 to 3 or 1 to 4 like that. After some time, what will happen? After some time, the electron jumping from lower orbit to the higher orbit, after some time they release the energy and come from higher orbit to the lower orbit. That is called as de-excitation. De-excitation means what? Electron coming from higher orbit to the lower orbit by releasing the amount of energy. See, generally we also, if we have more energy, what we will do? We will go to the excitation. మనం బయటికి వెళ్ళిపోతాం, బయటికి వెళ్ళిపోయి ప్లే గ్రౌండ్లో ఆడుకుంటాం, లేదంటే ఇంకా వేరే పనులు చేస్తాం. ఎగ్జైటేషన్కి వెళ్ళడం అంటుందా. కొద్దిసేపు తర్వాత ఎనర్జీ అంతా లాస్ అయిపోతుంది. ఎనర్జీ లాస్ అయినప్పుడు ఏమవుతుంది? విల్ జస్ట్ కమ్ టు ది హౌస్. మళ్ళీ ఏంది? ఇంటికి మెల్లగా వచ్చేస్తుంది. దాన్నే కమింగ్ టు ది గ్రౌండ్ స్టేట్ అంటుంది. సో ఎలక్ట్రాన్ అబ్జర్వ్ ఎనర్జీ అండ్ విల్ గో టు ది ఎగ్జైటెడ్ స్టేట్, దట్ ఈస్ lower orbit to the higher orbit. After some time they release the energy and will come from higher orbit to the lower orbit. This is called as de-excitation. If electron release energy, it jump from higher orbit to lower orbit. It jump from higher orbit to lower orbit. This is called as what? De-excitation. So during excitation and de-excitation, what is happening? During excitation, energy is absorbed by the electron. During de-excitation, energy is released by the electron. So whatever it may be, it is maybe excitation or it may be de-excitation, there will be change in the energy of the electron. So the change in energy of the electron during excitation and de-excitation, delta E is equals to E2 minus E1. Delta E is equals to E2 minus E1. See, for example, the electron is present in the first shell. This is the first shell. It has to go to third shell. So the electron absorbed energy. Electron is having earlier 2 kilojoules. Now it absorbed 4 kilojoules and went to the third. Ante 4 kilo. The energy. Electron present in the first shell, the energy is 2 kilojoules. Fourth shell, the energy is 4 kilojoules. So ikkadi nunchi ikkadiki vellinappudu the change in energy is how much? Delta E is equals to E2 means energy of the higher orbit. How much? 4. And E1 is the energy of lower orbit. How much? 2. So the change in energy will be how much? 2 kilojoules. Means if the electron has to jump from first shell to third shell, that electron should absorb how much amount of energy? 2 kilojoules of energy. Again it is coming from higher orbit to the lower orbit. Also the change in energy is how much? 2 kilojoules. But this time it is releasing. Higher orbit నుంచి lower orbit కి వచ్చేటప్పుడు 2 kilojoules రిలీజ్ చేయాలి. అంటే థర్డ్ షెల్ నుంచి ఫస్ట్ షెల్కి వచ్చేటప్పుడు 2 kilojoules రిలీజ్ చేయాలి. ఫస్ట్ షెల్ నుంచి థర్డ్ షెల్కి వెళ్ళేటప్పుడు 2 kilojoules అబ్జార్బ్ చేయాలి. That is what? Excitation of electron and de-excitation of electron. So during excitation and de-excitation of electron, the change in the energy delta E is equals to E2 minus E1. Delta E is equals to E2 minus E1. Delta E is change in energy during excitation and de-excitation. E2 is energy of higher orbit. Energy of higher orbit. And E1 is energy of lower orbit. E1 is energy of lower orbit, right? So delta E, change in energy is what? H nu. Energy, change in energy is nothing but what? Energy only, that is energy formula in the E is equals to H nu. H nu is equals to E2 minus E1, and nu is the frequency. If you want to know the change in frequency during excitation and de-excitation, you can calculate this by E2 minus E1 by H. This is change in frequency. E2 minus E1 by H. Okay. And the next. So these are some important postulates of Bohr's atomic model. According to the Bohr's atomic model, atom is a sphere-shaped particle, and the total mass of the atom is present at the center. Center lo untundi mass anta. Center lo em untundi? Nucleus untundi. Nucleus lo em untayi? Protons mariyu neutrons untayi. The protons mariyu neutrons రెండింటిని కలిపి మనం ఏమంటున్నాము? న్యూక్లియర్ అంటున్నాము. న్యూక్లియస్లో అల్టిమేట్గా ఉండే ఛార్జ్ ఏంటిది? పాజిటివ్ ఛార్జ్. ఎందుకంటే న్యూక్లియస్లో ప్రోటాన్స్ ఉంటాయి, న్యూట్రాన్స్ ఉంటాయి. ప్రోటాన్స్కి పాజిటివ్ ఛార్జ్ ఉంటుంది, న్యూట్రాన్స్కి జీరో ఛార్జ్ ఉంటుంది. సో అల్టిమేట్ ఛార్జ్ న్యూక్లియస్లో ఏముంటుంది? పాజిటివ్ ఛార్జ్ ఉంటుంది. దాన్ని న్యూక్లియర్ ఫోర్స్ ఆఫ్ అట్రాక్షన్ ఆర్ న్యూక్లియర్ ఛార్జ్ అంటారు. న్యూక్లియర్ ఛార్జ్ ఈజ్ వాట్ ఛార్జ్? పాజిటివ్ ఛార్జ్. అండ్ న్యూక్లియస్ బయట ఆర్బిట్స్లో ఏముంటాయి? ఎలక్ట్రాన్స్ ఉంటాయి. ఈ ఆర్బిట్స్ ఆర్ షెల్స్ ఆర్ ఎనర్జీ లెవెల్స్ అంటాం. వీటిని 1, 2, 3, 4 ఆర్ KLMN అనే వాటితో ఇండికేట్ చేస్తుంది. నెక్స్ట్, ఎలక్ట్రాన్ లోవర్ ఆర్బిట్ నుంచి హయ్యర్ ఆర్బిట్కి అని వెళ్ళినప్పుడు ఎగ్జైటేషన్ అంటున్నాం. హయ్యర్ ఆర్బిట్ నుంచి లోవర్ ఆర్బిట్కి వచ్చినప్పుడు డీఎగ్జైటేషన్ అంటాం. ఎగ్జైటేషన్లో ఎలక్ట్రాన్ ఏం చేస్తుంది? ఎనర్జీని అబ్జార్బ్ చేసుకుంటుంది. డీఎగ్జైటేషన్లో ఎలక్ట్రాన్ ఎనర్జీని రిలీజ్ చేస్తుంది. డ్యూరింగ్ ఎగ్జైటేషన్ అండ్ డీఎగ్జైటేషన్, వాట్ ఈస్ హ్యాపెనింగ్? దెర్ ఈస్ చేంజ్ ఇన్ ఎనర్జీ ఈస్ హ్యాపెనింగ్. The change in energy we are calling it as delta E is equals to E2 minus E1. Okay, these are the important postulates of Bohr's atomic model, and which we have written here. Ivanni Bohr's atomic model loni postulates. Okay, these are also same. And next we are going to see Bohr calculated the radius of orbit. Bohr calculated the radius of orbit. What orbit this is? Nth orbit. The radius of nth orbit is 0.529 into n square angstroms. This formula is for what atom? For hydrogen atom. Bohr calculate the radius of what? Hydrogen atom. Actually the radius of hydrogen atom Rn is equals to n square h square by 4 pi square mz E square. This is the formula to calculate the radius of electron present in the nth orbit. Radius of electron present in the nth orbit. Radius means what? It is the distance between the center of the nucleus to the electron, or distance between the center of the nucleus to the orbit, okay, in which the electron is present. Okay, see, this is the nucleus and we have electron in the, for example, third shell. You want to calculate this radius. This is the distance between the nucleus to the electron or nucleus to the shell in which this electron is present. How can you calculate? Radius of the electron present in what orbit? Nth orbit is equals to n square. N means what? Orbit in which electron is present. Orbit in which the electron is present. H is what? H is Planck's constant, and its value is how much? 6.625 into 10 to the power minus 34 joules kg second inverse. And for pi value is 3.14. Mass of electron, m is what? Mass of electron. Z is atomic number. Atomic number. Actually we don't write this for a hydrogen atom. We don't write that for hydrogen atom, because hydrogen atom atomic number is what? 1 only. E is charge on electron, and you know charge on electron, right? It is minus 1.602 into 10 to the power minus 19 coulomb. If you put all these values here, if you put all these values in this formula, you will be getting radius of nth orbit as 0.529 into n square, okay, angstroms. N is the orbit in which the electron is present. N is what? N is the orbit in which the electron is present, okay, and Rn is equals to 0.529 into n square into 10 to the power minus 8 centimeters. If you can convert angstroms into centimeters, it will be 10 to the power minus 8 centimeters. And same formula I will write, Rn is equals to 0.529 into 10 into n square into 10 to the power minus 10 meters. Meters lo convert this. And same thing, Rn is equals to 52.9 into n square into 10 to the power minus 12. I am adjusting 2 points here, so that this one will become 10 to the power minus 2 into 10 to the power minus 2. Sorry, minus 10 into minus 2. Minus 12. What is this? Meters. So 10 to the power minus 12 meters is equals to 1 picometer, right? 10 to the power minus 12 is equals to 1 picometer. So Rn is equals to 52.9 into n square. In square, what this is? Picometers. Picometers lo radius. This is the radius in pico. So this formula is applicable only to the hydrogen atoms. But we are also having formula to calculate the hydrogen like atoms. Radius of hydrogen like atoms. Hydrogen like atoms. Radius of hydrogen like atom. This is very, very important formula, and in JEE mains and NEET exams many times the question will come from this formula. That is, you will be asked to calculate the radius of electron present in the first orbit or second orbit or third orbit in angstroms or centimeters or meters or picometers. So radius of hydrogen like atoms. Hydrogen like atoms means what? Single electron atoms. Helium plus, helium atomic number is 2. 2 electrons are there. Helium plus means what? 1 electron is lost. And helium plus, next lithium plus 2, beryllium plus 3, all these are hydrogen like atoms. For hydrogen like atoms, Rn is equals to 0.529 into n square by z angstroms, and Rn is equals to 0.529 into n square by z into 10 to the power minus 8 centimeters, or else 0.529 into n square by z into 10 to the power of minus 10 meters, or 52.9 into n square by z picometer. So all these are the formulas to calculate the radius of nth orbit of hydrogen like atoms, right? And he also calculated the energy of nth orbit. Energy of nth orbit En is equals to minus 13.6 into z square by n square, electron volt per atom. This is the formula to calculate the energy of electron present in the nth orbit. So these are the important postulates of Bohr's atomic model. And next we are going to study hydrogen spectrum. So the next topic is hydrogen spectrum. So hydrogen spectrum means when hydrogen gas at low pressure is taken in the discharge tube and the light emitted on passing electric discharge is examined with a spectroscope. The spectrum obtained is called as emission spectrum of hydrogen, which contain large number of lines which are grouped into the 5 different series. See carefully now. So what happened means Bohr took some hydrogen gas in a container having what pressure? Low pressure. He passed some electromagnetic radiations of different wavelength and different frequencies through it. This electromagnetic radiation is absorbed by these gaseous molecules in them, and some of the frequencies and wavelengths are absorbed by the gaseous molecules, and it emitted remaining frequencies, and these remaining frequencies are analyzed by a spectroscope. So when they have analyzed the remaining frequencies, what they have got is they got here, which are grouped into 5 different series. They got 5 series. One series is Lyman series, Balmer series, Paschen series, Brackett series, Fund series, and Humphreys series. Okay, but in syllabus you will be having only up to here Lyman, Balmer, Paschen, Brackett, Fund. Okay, already we have studied in Bohr's atomic model, whenever electron absorb energy, jump from lower orbit to the higher orbit, which we are calling it as what? Excitation. And after some time what will happen? The electron will release energy and will come from higher orbit to the lower orbit, that is called as de-excitation. So the same thing is happening here. See carefully now. So in this one, that is, he passed electromagnetic radiation through what? This gas. In this gas hydrogen molecules are there, and hydrogen molecules consist of hydrogen atoms. In hydrogen atoms electrons are present, and this electromagnetic radiation is absorbed by what? Electrons, and these electrons are jumping from higher orbit to the lower orbit, lower orbit to the higher orbit, because they have absorbed energy, right? Tarvata, kodisep tarvata, they are releasing energy and coming from higher to the lower. Av energy ni release chesi higher orbital nunchi lower orbital ki raavadam start ayindi. Danne manam emantunnam de-excitation antum. So the released energy is analyzed through a spectrometer or spectroscope, and he got 5 series of lines here. Any spectrums form in 5 series of lines. This is 1 series of line, 2 series of lines, 3rd series of line, and you may have 4th series of line like this, and you may have 5th series of lines. Ante they have passed the electromagnetic radiation or light through hydrogen gas. Hydrogen gas lo unde hydrogen atoms lo electrons untayi. And electromagnetic radiation is ultimately passed through electrons. Electrons are radiation absorb cheskoni, energy absorb cheskoni, lower orbital nunchi higher orbital ki jump ayinavi. Jump ayina tarvata emaindi, kodsep tarvata they started releasing energy, and that released energy we have put it on the photographic plate, and that image produced there is called as what image? Emission image or emission spectrum. We have already studied. The image recorded by the emitted radiation is called as emission spectrum. So hydrogen atom electron absorb cheskoni hydrogen atom energy absorb cheskoni lower orbit nunchi higher orbit ki velnayi, higher orbit nunchi lower orbit ki vachinappudu energy release chesinayi. Aa release ayina energy ni ikkada manam ఏం చేసినాం? రికార్డ్ చేసినాం. కాబట్టి ఇక్కడ ఫామ్ అయిన స్పెక్ట్రమ్ ఏమంటాం? ఎమిషన్ స్పెక్ట్రమ్ అంటాము. ఈ ఎమిషన్ స్పెక్ట్రమ్లో వాళ్ళకి 5 సిరీస్ ఆఫ్ లైన్స్ కనబడ్డాయి. ఎన్ని సిరీస్ ఆఫ్ లైన్స్ కనబడ్డవి? 5 సిరీస్ ఆఫ్ లైన్స్ కనబడ్డాయి. ఎందుకు అంటే సీ కేర్ఫుల్లీ. సో సమ్ ఎలక్ట్రాన్స్, ఫ్యూ ఎలక్ట్రాన్స్ లైక్ few electrons absorbed maximum amount of energy. Few electrons absorb how much amount of energy? Maximum amount of energy. They went from lower orbit to the very higher orbit. They maximum amount of energy ని అబ్జర్వ్ చేసుకున్నప్పుడు ఎక్కడికి వెళ్తాయి అమ్మా అవి? లోవర్ ఆర్బిట్ నుంచి హయ్యర్ ఆర్బిట్కి వెళ్తాయి. కొన్ని తక్కువ ఎనర్జీని అబ్జర్వ్ చేసుకున్నాయి, 6th లెవెల్కి వెళ్తాయి. కొన్ని ఇంకా తక్కువ ఎనర్జీని అబ్జర్వ్ చేసుకున్నాయి, 7th లెవెల్కి వెళ్తాయి, 5th లెవెల్కి వెళ్తాయి. అట్లా they, based on the amount of energy that they have absorbed, they can go to their respective energy levels or respective orbits. First orbit, second orbit, third orbit, fourth orbit, fifth. So maximum energy ni observe cheskune ekkadiki veltayi? Infinite level ki veltayi. Minimum energy ni observe cheskune ekkadiki veltayi? First nunchi second maatrame veltayi. Ellin tarvata koddisepu tarvata, after some time, what will happen? The electrons will start coming from higher energy level to the lower energy level because they started releasing energy. ఒకవేళ ఒక ఎలక్ట్రాన్ 7th ఆర్బిట్లోకి వెళ్ళింది అంటే దే అబ్జార్బ్ మ్యాక్సిమం ఎనర్జీ. ఆ 7th ఆర్బిట్లోకి వెళ్ళి ఎంతైతే ఎనర్జీని అబ్జార్బ్ చేసుకుందో అంతే సేమ్ ఎనర్జీని రిలీజ్ చేసింది అనుకోండి, దే విల్ కమ్ ఫ్రమ్ 7 to 1. ఎక్కడికి వెళ్తుంది అది? 7 to 1కి డీఎక్సిట్. ఒక ఎలక్ట్రాన్ 6thలోకి వెళ్ళింది, ఎనర్జీని అబ్జర్వ్ చేసుకుంది, 6thలోకి వెళ్ళింది, సేమ్ ఎంత ఎనర్జీని అబ్జర్వ్ చేసుకుందో అంతే రిలీజ్ చేసింది అనుకోండి, మళ్ళీ ఎక్కడికి వస్తుంది? ఫస్ట్లోకి వస్తుంది. అంటే దట్ ఎలక్ట్రాన్, దిస్ ఎలక్ట్రాన్ అబ్జర్బ్ 10 kilojoules ఫర్ ఎగ్జాంపుల్, దిస్ ఎలక్ట్రాన్ అబ్జర్బ్ 8, దిస్ ఎలక్ట్రాన్ అబ్జర్బ్ 6 kilojoules. కానీ ఎంతైతే అబ్జర్వ్ చేసుకుందో అంత రిలీజ్ చేసింది. అందుకని ఎక్కడికి వచ్చినాయి? ఫస్ట్ లెవెల్కి వచ్చినాయి. ద ఎలక్ట్రాన్స్ ఆర్ కమింగ్ టు ది ఫస్ట్ లెవెల్. ఫస్ట్ లెవెల్కి వచ్చినప్పుడు మాత్రమే they are releasing maximum energy. How much amount of energy they are absorbed. కానీ ఒక ఎలక్ట్రాన్ మ్యాక్సిమం ఎనర్జీని అబ్జర్వ్ చేసుకొని అంటే 10 kilojoules అబ్జర్వ్ చేసుకొని 8 kilojoules మాత్రమే రిలీజ్ చేసింది అంటే అది ఫస్ట్ లెవెల్కి వస్తుందా? రాదు. ఎంతైతే అబ్జర్వ్ చేసుకుందో అంత ఎనర్జీ రిలీజ్ చేస్తే ఫస్ట్ లెవెల్కి వస్తుంది. కానీ దిస్ ఈజ్ నాట్ రిలీజింగ్ all the energy that it is absorbed. That's why it is coming to the second energy level. And one more electron you have. This is absorbed 10 kilojoules, but it is emitting 6 kilojoules only. Ante meaning endi? It is coming to third level. And like that, based on the amounts of energies that they have absorbed and releasing, they will be coming into the different energy levels. ఏవైతే ఎలక్ట్రాన్స్ ఎనీ హయ్యర్ ఎనర్జీ లెవెల్ నుంచి ఫస్ట్ లెవెల్కి వచ్చినాయో ఆ ఎలక్ట్రాన్స్ ఏమంటారు? లైమన్ సిరీస్ అన్నారు. దీస్ ఆర్ కాల్డ్ యాజ్ వాట్ సిరీస్? లైమన్ సిరీస్. ద సిరీస్ ఆఫ్ లైన్స్ ఫార్మ్డ్ హియర్ ఈస్ కాల్డ్ యాజ్ లైమన్ సిరీస్. లైమన్ సిరీస్లో ఎలక్ట్రాన్ ఎక్కడి నుంచి ఎక్కడికి వస్తుంది? ఫ్రమ్ ఎనీ హయ్యర్ ఎనర్జీ లెవెల్ టు ది n is equals to 1 లెవెల్కి వస్తుంది. లైమన్ సిరీస్కి వచ్చినప్పుడు దీస్ ఎలక్ట్రాన్స్ ఆర్ రిలీజింగ్ ఎనర్జీ whose frequency and wavelength is equals to ultraviolet rays. అల్ట్రావైలెట్ రేస్కి ఎంతైతే ఫ్రీక్వెన్సీ, ఎంతైతే వేవ్ లెంత్ ఉంటుందో ఆ సేమ్ వేవ్ లెంత్ని దట్ ఎలక్ట్రాన్స్ అంటే ఎనీ హయ్యర్ ఎనర్జీ లెవెల్ నుంచి n is equals to 1 ఫస్ట్ లెవెల్కి వచ్చే ఎలక్ట్రాన్స్కి అంతే ఫ్రీక్వెన్సీ, అంతే వేవ్ లెంత్ని రిలీజ్ చేస్తాయి అవి. They release the radiations which are equals to the wavelength and frequencies of ultraviolet region. Lyman series, the lines present in the Lyman series will release the radiation equals to the what? Radiation equals to the wavelength of UV radiation and frequency of UV radiation. And Balmer series now. Balmer series లోకి వచ్చే ఎలక్ట్రాన్స్ ఎక్కడి నుంచి వస్తాయి? ఇవి ఎనీ హయ్యర్ లెవెల్ నుంచి ఏ లెవెల్కి వస్తాయి? సెకండ్ షెల్లోకి వస్తాయి. లైమన్ సిరీస్లో n1 is what? In Lyman series, n1 is 1. It means the electron will come from any higher energy level to first level. But any higher energy electron will be coming from second or third or fourth or fifth or sixth or seventh. Electron is coming from any higher energy level to first level. The series of lines observed is called as what series? Lyman series. Okay. And what is the radiation, or what are the frequencies and wavelengths that are emitted by the electrons present in the Lyman series? They are equal to what? Ultraviolet radiation. The frequencies and wavelengths released by the electrons present in the Lyman series is equals to what radiation? Ultraviolet radiation. Next, coming to the Balmer series. Balmer series, the electron will come to what energy level? Second energy level. From where? From third shell or fourth shell or fifth shell or sixth shell or seventh shell. So Balmer series lo unde electrons ekkadi nunchi vastunnai? Third lo nunchi gaani, fourth lo nunchi gaani, fifth lo nunchi gaani, sixth lo nunchi gaani, seventh lo nunchi gaani, or infinity shell nunchi. Ekkadiki vastayi avi? Second shell ki vastayi. They are coming from third, fourth, sixth, seventh and infinity, and will come to our where? Second shell. So that electrons will be releasing. పైనుంచి కిందికి వచ్చినప్పుడు electrons ఏం చేస్తాయి? ఎనర్జీని రిలీజ్ చేస్తాయి. That electrons are releasing the energy equals to the visible radiation, or that electrons are releasing radiation whose wavelength and frequencies are equals to visible radiations. Okay. And Paschen series means the electron will come from third shell, come to third shell, not from third shell, come to third shell. From what shells? Third shell, fourth shell, fifth shell, sixth shell and seventh shell, so on. And these electrons are releasing the frequency and wavelengths which are equals to the frequency and wavelengths of what radiation? Infrared radiation. Paschen series loki vache electrons, they are releasing the radiations having frequencies and wavelengths which are equals to the wavelength and frequencies of infrared radiation. Okay. Like that bracket series also. Bracket series lo ante electron ekkadiki vastadi? Fourth ki vastadi. Ekkadi nunchi vastadi? Fifth nunchi raavochu, sixth nunchi raavochu, seventh nunchi raavochu. P fund series lo electron ekkadiki vastadi? Fifth loki vastadi. ఎక్కడి నుంచి రావచ్చు? అది సిక్స్త్ నుంచి రావచ్చు, సెవెంత్ నుంచి రావచ్చు, ఇన్ఫినిటీ నుంచి కూడా రావచ్చు. అప్పుడు దే విల్ రిలీజ్ ది రేడియేషన్ ఈజ్ ఈక్వల్స్ టు వాట్ వేవ్ లెంత్ అండ్ వాట్ ఫ్రీక్వెన్సీ? దే విల్ రిలీజ్ ది రేడియేషన్ ఈక్వల్స్ ది frequency and wavelength of infrared radiation. What infrared? Far infrared radiation. Okay. So now see carefully. So this is the very first line, H alpha line we are calling. In any series, the very first line means the electron is coming from very lower orbit. For first series, Lyman series, the very lower orbit from which the electron is coming is what? Second shell nunchi vastadi. That is called as H alpha line. And the next line is called as H beta line, next line is called as H alpha beta, H gamma line, and like that this last line is called as H infinity line. Actually we have written here 7, but the very last line of in any series is H infinity line. So H infinity line lo this line is observed because this particular electron, it is coming from very higher energy level to the very lower energy level. It means it is releasing as much as energy that it is absorbed. It means the energy released in case of H infinity line is maximum. Energy is maximum. We know that formula is E is equals to what? E is equals to H nu. Sorry. E is equals to H nu. We can write that E is equals to Hc by lambda. Right? So energy and frequency is directly proportional. So H infinity line is having how much energy? Maximum energy. It is releasing maximum energy. Why it is releasing maximum energy? It is releasing as much as energy that it is absorbed. That is the reason why it is coming from very higher infinity level to the 1. So E max, H alpha line ki energy is what? Maximum. It releases maximum energy. E and nu is directly proportional. So nu is also what? Maximum here. And E and lambda is inversely proportional. Kabatti lambda is minimum for this one. Lambda is minimum. This is very, very important thing. And you know that E is equals to H C into 1 by lambda. 1 by lambda is equals to nu bar. HC nu bar. 1 by lambda is equals to nu bar means what? E is directly proportional to nu bar, right? E is directly proportional to nu bar. So if E is maximum, nu bar is also maximum. Nu bar is also maximum. Wave number is also maximum. If any electron coming from very higher energy level or infinity level to the ground state, it is having maximum energy it is releasing, and its wavelength that is released is maximum, and wavelength that is released is minimum, and frequency that it is released is maximum. In this series only H alpha line. Now H alpha line is coming just from 2 to 1. It means it releases less amount of energy. It releases less amount of energy. And the energy of E alpha line is minimum. If energy minimum, nu is also minimum. Nu bar is also minimum. But what is maximum? Lambda is maximum. Frequency takku undi ante wavelength etluntade? Ekku untadi. So in any series this is the order. In any series see, in any series this is H alpha line, H beta, H gamma and H infinity. H alpha, beta, gamma and infinity, H infinity. Both are looking same but these are different. H alpha line, this is H alpha. H alpha means energy is minimum. If energy is minimum and frequency is also minimum, nu bar is also minimum, but lambda is maximum. And H infinity line, energy is maximum, nu is maximum, nu bar is also maximum, and lambda is minimum. This you have to remember. Okay. And next, this is about the Lyman series. It was found in the ultraviolet region by Lyman. N1 is always 1 in Lyman series. N2 will be 2, 3, 4, where N2 is higher energy state, from where the electron is de-excited. Same thing. Okay. Here also we have discussed that. Lyman series la N1 entity 1, Balmer series N1 2, Passion series N1 3, Bracket series N1 4, P1 series N1 5. If N1 is 1, N2 will be from 2, 3, 4, because the electron which should come from second or third, because N1 is 1. Like that it is. And the wave number for a single electron species like He plus, Li2 plus and Be3 plus can be calculated by the following equation. What is that equation? I will write now. Wave number nu bar is equals to 1 by lambda is equals to, I am writing this for hydrogen, RH into 1 by N1 square minus 1 by N2 square. So here nu bar is wave number, lambda is wavelength, RH is Rydberg constant. Rydberg constant, whose value is equals to 109,677 centimeter inverse, whose value is 109,667 centimeter inverse, and N1 is the lower orbit and N2 is the higher orbit. This is the formula to calculate what? Wave number or wavelength of any electron which is coming from higher energy level to the lower energy level. We are calculating wave number or wavelength of the electron that is coming from any higher energy level to the lower energy level. Okay. And one more important thing, number of spectral lines possible when electron coming from higher energy level to lower energy level. Is equals to delta n into delta n plus 1 by 2. That is nothing but delta n means what? N2 minus N1, higher orbit minus lower orbit, into N2 minus N1, into N2 minus N1 plus 1 by N2 is the higher orbit, N1 is the lower. So number of spectral lines, when electron is coming from higher energy level to the lower energy level, what will happen? Many lines are formed. How many number of lines are formed means, when electron is coming from any higher energy level to the lower energy level, the formula is delta n into delta n plus 1 by 2. And one more formula is there, that is number of lines formed when electron coming from higher energy level to the ground state, higher to ground state. The formula is n into n minus 1 by 2. Here n is higher energy level. Here n is higher energy level. Okay, these are the important formulas which you need to remember in this thing. Next one is dual nature of matter. So light exhibit different properties such as diffraction, interference, photoelectric effect, Compton effect, okay, and reflection, refraction. So these are the properties of electromagnetic radiation or light. Okay. Now, some of these properties were explained. The phenomena of diffraction property, interference is explained by wave nature of light. Some properties of light are explained by the wave nature. Some properties of light is explained by the particle nature. It means they have concluded that light or electromagnetic radiation are having wave nature and as well as particle nature. This was said by the Planck's quantum theory, right? So that is what is called as dual nature of matter or dual nature of matter. But the phenomena of photoelectric effect and Compton effect can be explained by the particle nature of matter. So wave nature explains what? Diffraction and interference, and Compton effect and photoelectric effect was explained by the particle nature of the light. Thus light has dual nature. De Broglie proposed that matter like radiation should also exhibit dual behavior. Light elagaithe dual behavior undo, wave nature and particle nature undo, matter ki kuda dual behavior untadani explain chestaru. Who will explain that? De Broglie. how he explained means, see, according to the Planck's quantum theory, he related the Planck's quantum theory. Planck's quantum theory, what is that? E is proportional to nu, so that E is equals to h nu, so that E is equals to hc by lambda. This is equation 1. And he took Einstein mass and energy relation. Einstein mass energy conversion or conservation. Einstein mass energy conservation theory. Mass energy conservation is what? E is equals to mc square, right? So energy is equals to the product of mass of the body and velocity of the light. For example, what is the energy of me, particle? As a particle, the energy of me is mass of mine and velocity of light. You have to square it. That is the energy. For example, my mass is 85 kgs. 85 kgs into 3 into 10 to the power of 10 centimeters to the power square. So that is mass exhibited as energy exhibited by me. Energy exhibited by any body is equals to mass of the body and velocity of the light. So he combined these two equations. Equation 1 and equation 2 both are energies only. So that hc by lambda is equals to mc square. This c square and this c will be cancelled. So that h by lambda is equals to mc. Now lambda is equals to h by mc. Wavelength of the particle is equals to the h by mc. M is mass of the body and c is velocity of light. C is velocity of light is written as v. Lambda is equals to h by mv. So lambda is equals to h by p. P is the momentum. M is mass, v is velocity of the particle. So mass into velocity is momentum. So this is de Broglie wave equation. De Broglie wave equation. De Broglie wave equation. So what de Broglie suggested? Like electromagnetic radiation is having wave nature and particle nature. Like electromagnetic radiation, the microscopic particles are also having both wave nature and particle nature. This momentum indicates particle nature of the matter, and this lambda indicates wave nature of the matter. Lambda indicates wave nature of the matter. So this is de Broglie wave equation. We have some problems based on this. And this de Broglie wave equation is mainly the electron moving with high speed possesses both the particle nature and wave nature. And de Broglie wave equation is mainly suitable for what? Microscopic particles like electron. So now de Broglie concluded that this electron present in the orbit and it is moving around the nucleus is having both particle nature and wave nature. Is having both particle nature and wave nature. It means, see, and Bohr said that MVR is equals to NH by 2 pi, right? MVR is equals to NH by 2 pi. What de Broglie said is, this electron present in the orbit will be undergoing a constructive interference. Constructive interference means here 2 pi r, circumference of the wave is 2 pi r is equals to n lambda, that will be calling as what? A constructive interference. The electron is present, electron is rotating around the nucleus in a circular path in constructive wave, otherwise destructive wave. Destructive wave means the two ends of the wave will not join. Here 2 pi r is not equals to n lambda. See carefully now, 2 pi r is equals to n lambda, Okay, 2 pi r is equals to n lambda. Lambda is what? 2 pi r is equals to n. Lambda is h by mb. Now bring this to here. MVR is equals to NH by 2 pi. According to this thing, de Broglie wave equation, 2 pi r is equals to n lambda, 2 pi r is equals to lambda plus name rasnamu h by mv rasnamu. mv ni తీసుకెళ్తే 2 pi it వస్తుంది. mvr is equals to nh by 2 pi is what? Angular momentum according to Bohr. Angular momentum according to Bohr's atomic model. Angular momentum according to Bohr's atomic model. Okay. Now, next one is Heisenberg Uncertainty Principle. According to Heisenberg, when electron is revolving around the nucleus, this is nucleus and this is electron, we cannot simultaneously and exactly locate its position and its momentum. We cannot simultaneously locate its position and its momentum. There will be some uncertainty in the position and momentum. Okay, that is what is called as Heisenberg Uncertainty Principle. Heisenberg ఏమని చెప్తారంటే ఎలక్ట్రాన్ న్యూక్లియస్ చుట్టూ రౌండ్ తిరుగుతుంటే దాని యొక్క పొజిషన్ని మూమెంటమ్ని ఎట్ ఎ టైం ఎగ్జాక్ట్గా కనుక్కోలేమని చెప్తారు. ఎందుకంటే వెన్ ఎలక్ట్రాన్ ఈజ్ రివాల్వింగ్ అరౌండ్ ది న్యూక్లియస్, ఫర్ ఎగ్జాంపుల్ వీ హ్యావ్ డిసైడెడ్ ఇట్స్ పొజిషన్ and it is continuously rotating around the nucleus. While we are calculating its momentum, the position will change. If you are calculating the position, its momentum will be changed. If you are calculating the momentum, its position will be changed. It means you cannot accurately calculate both the values at a time simultaneously. That is what this Heisenberg understanding. It is impossible to determine simultaneously and accurately the exact position and momentum. Momentum means velocity of subatomic particle like electron in an atom. One can determine the position of particle very accurately, and then the determination of its velocity becomes less accurate. Simultaneously, one can determine the velocity of particle very accurately. What will be uncertain now? Uncertain will be position. So there will be some uncertainty in the either position or in the momentum of the electron or velocity of the electron which is revolving around the nucleus. That is called as uncertainty principle. Uncertainty principle is what? It is impossible to determine the exact position and exact momentum or velocity of electron, okay, simultaneously. That is what uncertainty principle. Uncertainty principle, he made one statement, like equation, delta x into delta p is greater than or equals to h by 4 pi. H by 4 pi. Delta x and delta p is greater than or equals to h by 4 pi. Right? So delta x is uncertainty in position. Uncertainty in position, and delta p is uncertainty in momentum. H is Planck's constant. H is Planck's constant, 4 pi. So I am writing this delta x into m delta v. P is what? M delta v, sorry. M delta v is greater than or equals to h by 4 pi. And I can write delta x is equals, delta x into delta v is greater than or equals to h by 4 pi here. So this is a uncertainty principle. There is always some uncertainty while measuring what? Position and velocity of the atomic particle, that is electron. We will be doing some problems based on this. What is the wavelength of light emitted when the electron in a hydrogen atom undergoes transition from a energy level within n is equals to 4 to n is equals to 2? This is the question. What you have to calculate? Wavelength of light emitted when the electron in a hydrogen atom undergoing transition from what to what? Within n is equals to 4 నుంచి n is equals to 2 కి ట్రాన్సిషన్ జరిగింది. అప్పుడు వేవ్ లెంత్ లాంబ్డా కనుక్కోవాలి. హౌ మచ్? వాట్ ఈస్ ది ఫార్ములా? వేవ్ నెంబర్ ఫార్ములా ఉంది. వేవ్ నెంబర్ ఈజ్ ఈక్వల్స్ టు 1 బై లాంబ్డా ఈజ్ ఈక్వల్స్ టు what? RH into Z square into 1 by n1 square minus 1 by n2 square, right? See carefully. So if you know the nu bar, you can calculate lambda. You just bring lambda here, nu bar will come here. So lambda is equals to 1 by nu bar, so that you will be getting lambda. So RH is value is 109677 into Z square means hydrogen atom 1 square atomic number into 1 by n1 square. n1 in the 2, lower orbit enta 2. 1 by 2 square minus 1 by 4 square, right? So this is 109677 into 2. How much you will be getting this one? This one will be 4 and this one will be 16. 16 into 4 is 64. 64. And here you will be getting how much? 16. Here 16 minus 4. Okay. How much you will be getting? This is 109677 into 16 minus 4 is 12. 12 by 64. 12 by 64 means how much? How many times it will go? 632. 3. 16. 3 by 16. 3 by 16. So we'll do it in the calculator. Okay. 3 by 16 is how much? 0.1875 is equals to 109677 into 0.1875. So multiply these two. That is into 109677. This is equals to 20,564.4375. 4375 nu bar. How much? What is this? Nu bar means centimeter inverse. Wavelength you want. This is nu bar value. What do you want? Lambda you want. Lambda is equals to 1 by nu bar. Nu bar is equals to 1 by lambda. Lambda is equals to 1 by nu bar. 1 by 20,564.43. How much it will be? Equals to 4.8 into 10 to the power minus 5 centimeters. This is the answer. Okay. And next question. Hydrogen atoms are de-excited from N shell. N means what? K, L, M, N. N means fourth shell. Fourth shell nunchi de-excited. Spectral lines produced in the emission spectrum. Spectral lines produced in the emission spectrum are how many? So a hydrogen atom, the electrons are de-exciting from what to what? N shell. Fourth shell nunchi de-excite aitunnai. అప్పుడు ఫార్ములా ఏంది? నెంబర్ ఆఫ్ లైన్స్. నెంబర్ ఆఫ్ లైన్స్ ఫార్ములా ఈజ్ ఈక్వల్స్ టు డెల్టా ఎన్ ఇంటూ డెల్టా ఎన్ ప్లస్ 1 by 2. డెల్టా ఎన్ మీన్స్ వాట్? n2 minus n1. Here n2 is 4, n1 is 1. ఫోర్త్ సెల్ నుంచి వస్తుంది. 4 minus 1 into 4 minus 1 plus 1 by 4 minus 1 is 3. Here 3 plus 1 is 4 again. 4 by 2 is 2. 3 into 2 is how many? 6 lines. How many lines are produced? 6 lines are produced. When an electron is jumping from fourth shell to the second shell, how many lines are produced? 6 lines. Fourth shell to the first shell. How many lines are produced? 6 lines are produced. Okay. And next one. Calculate the wave number of first spectral line in Lyman series of helium plus. Wave number, nu bar is equals to 1 by lambda. We need not to calculate 1 by lambda value, but nu bar is equals to 1 by lambda is equals to RH into Z square into 1 by N1 square minus 1 by N2 square, right? So nu bar is equals to RH value 109677 into Z square, helium plus. Helium plus means helium atomic number is 2 square into 1 by N1 square. N1 square means he is asking us to calculate the wave number of first spectral line in the Lyman series. Lyman series means N1 is equals to 1. First spectral line means what? N2 is equals to 2. Second spectral line means what? N1 is equals to 1, N2 is equals to 3. Third spectral line ante N2 is equals to 4. Lyman series means N1 is always 1. N1 is always 1 and first spectral line kabatti N2 value 2 square. So that this one will be equals to 109677 into 4 into, so this one will be 4, and so that you will be getting 4 here and 1 here. So 109677 into 4 into, this one will be 3 by 4. Calculate. 3 divided by 4 is 0.75 into 4 into 109677. 0.75 into 4 is 3. 0.75 into 4 is 3 into 109677 into 109677. That is equals to 329031. This is the wave number. Wave number of the wave where centimeter inverse answer. It is coming from what shell to what shell? This first spectral line. First spectral line means N2 is equals to 2, N1 is equals to 1. Next question. Find the momentum of particle whose de Broglie wavelength is 1 angstrom. Momentum lambda is equals to h by p. He is asking us to calculate p. De Broglie wave equation is p is equals to h by lambda. H is equals to 6.625 into 10 to the power minus 34 joule second kg by next lambda value 1 angstrom. 1 angstrom is equals to, if you can change this in the meters, you will be getting 1 into 10 to the power minus 10 meters, right? So this one is equals to the 6.625 into 10 to the power minus 34 into 10 to the power 10 will be equals to 6.625 into 10 to the power minus 20. This is the momentum. Okay, and next one, this is the last problem of this session. What is the product of uncertainties in position and velocity of electron? So position and velocity, delta x and delta p, formula is greater than or equals to h by 4 pi. Velocity kabatti delta x into m delta v is greater than or equals to h by 4 pi. Only velocity and position lo adugutundi. Kabatti delta x into delta v, uncertainty in the velocity and uncertainty in the position is equals to, is greater than or equals to the h by 4 pi m. So delta x into delta v is greater than or equals to h by 4 pi m, that is 6.625 into 10 to the power minus 34 by 4 value is what? 4 only, pi is 3.14 and m is mass of electron. M is mass of electron, that is 9.1 into 10 to the power minus 31. 10 to the power minus 31 kg into 10 to the power minus 31 kg. So what will happen? 6.625 into 10 to the power minus 34 into 10 to the power plus 31 pi this color by 4 into 3.14. 4 into 3.14 is how much? 4 into 3.14 is 12 point, I am writing here, this is 12.4 into 3.14 is equals to 12.56 paina 6.625 into 10 to the power how much? 34 minus 31, 10 to the power minus 3. So 6.625 divided by 12.56. This is 0.527 into 10 to the power minus 3. That is nothing but 5.27 into 10 to the power minus 2. This is the uncertainty in the position and velocity. The product of uncertainty in the position and velocities of the electron. Okay. This is about today's lecture. We have covered spectrum, Bohr's atomic model, Heisenberg uncertainty principle and de Broglie wave equation. And in the next class we are going to cover quantum numbers, electronic configuration and shapes of orbitals. With that we will finish this atomic structure chapter, and the next chapter that we are going to cover is periodic table. Okay. Thank you very much for today. Thank you all.